Hello, welcome back. In this segment, I'm going to talk about the risk of using regular random function to generate cryptographic keys. In particular, something like srand or rand function that is part of standard libraries. Here is a very simple and easy to break way of generating cryptographic key. All we are doing here is that we are taking the key size as the input. Okay, key size could be in terms of bytes, 16 byte or 32 byte or whatever you need for your cryptographic system. Here we are creating an array of that many bytes that you need. And then we are using the srand function. This printf is just for debug purpose. Yeah, we use the srand function initialized with time of null, that means the current time. And then what we do, we keep on calling the rand function and we do modulo 256 because our goal is to fill up the array of unsigned char, right, as a byte array. So by doing mod 256, we are sure the value will be from 0 through 255. So this is the bad way of generating a cryptographic key. There's a good way, which I will come back later. But let's focus on how this can be broken, okay? So I put together this keygen main function, which will generate 16-byte key or 128-bit key. And I'm going to now show you very quickly that particular function, okay? It generated a bad key, okay? But let us assume you know the time at which the key was generated, okay? Which is not a terrible assumption. In many cases, you may know the interval in which the key was generated, okay? Let's assume the key was generated between 1048 and 1050, okay? So the date function to figure out how many seconds were lost since 1970. So we use that. So I will put the date, month, year, month, day, and then the time, which is 1048, and I will make another assumption. It is generated between 1048 and 1049 or 1050. So now we know these two numbers, right? We will use these two numbers to generate all possible keys, and then I will show you the bad key is part of that all possible key list. And what I'm doing here is I create a file called keys.txt, open it in write mode, and I will try all possible keys in that interval. Okay, that's what I'm going to try. As you can see, all I'm doing is initialize the srand function for all possible seconds between these two intervals, right, one by one. And for each srand initialization, we keep calling the rand key size times. So I have hard-coded key size to be 16 bytes for demo purpose. That's basically it. Now let's compile and see whether we can find out the bad key in the list of keys. You see here, this is exactly this key that was generated. So instead of trying all possible 16-byte keys, the attacker can narrow down the search space if he knows the interval. So in this case, we tried within 2 minutes interval, how many keys he has to try. Only 121 keys, which is significantly less than 2 power 128, right? 2 power 128 means enormous. Too many keys to try in the worst case, brute force. But here it's only 120 keys to decrypt some message. So the main message is that if you were using something like the keygen that I have shown using the traditional srand rand function, you may want to change your key generation strategy. Okay, now I will show you how to generate the key in a good way, right? This is bad, which we show is bad. And now we do the same with, yeah, this is the good way of generating the key. Okay, so here is the keygen good, which essentially opens the dev random file and uses the file read function to read how many bytes do we need. We need key size bytes, and we multiply it by size of unsigned chart to tell us how many bytes we need. Okay, we read it and into this particular key array. Okay, I hope this is helpful. That's all. Thank you very much.